Okay, today we're going over 7.1 roots and radical expressions. So we know that if it says something like the square root of 4, we read it as the square root of 4, and if we're finding both of the solutions, it would be plus and minus 2. So if there's no number written in, then the square root of 4 is the same as knowing that the index is a 2. That's the same thing. So now we're going to get into ones of higher index radicals, such as cube roots. So let's first look at some perfect cubes. And what I mean by that is if I take, for example, the cube root of 8, this means that if I multiply a number 3 times, it will get me back to 8. So the cube root of 8 is a 2. Because 2 times 2 times 2 is 8. So some perfect cubes here will be, well, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed, 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1000. So see, these are some of the perfect cubes that we should become familiar with. So when we see these numbers, we should know they are perfect cubes. So let's go over some. For example, if I have, let's say, the cube root of negative 64. Well, I know that the cube root of 64 is 4, but now it's a negative underneath. So if the index is odd, if it's an odd index, you can have a negative radicand. And the radicand is the number underneath. So this is going to be a negative 4. And that's because negative 4 times negative 4 times negative 4 will be 4. Negative 4 times negative 4 is a 16. And 16 times negative 4 is negative 64. So that's why the cube root of negative 64 is negative 4. We can also do these with some fractions. For example, if I have the cube root of 1 over 27, this is the same as writing the cube root of 1 over the cube root of 27. The cube root of 1 is a 1, and the cube root of 27 is a 3. So it's a 1/3. Okay, so now we can go over the fourth roots. And the easiest way to do fourth roots is going to be to take the square root. You're going to take the square root twice. Okay, so let's say, for example, we have the fourth root of 81. If we're finding both of the solutions, we're going to take the square root of 81, which is a 9, and the square root of 9 is 3, or plus and minus 3. So we just take the square root twice. Okay, let's say we are putting in some variables now. So if we have variables in here, let's say, for example, I have the square root of 4x to the 6th. So we know that this number written in here is a 2 if there's no number written in. So if there's a variable, the way you're going to solve this is you're going to take the base of the variable, and the exponent is going to be the power over the root. For example, the power here is a 6 and the root is a 2. So we know if we're talking about the positive value is called the principal root. So the square root of 4 is a 2. And then if I'm doing the square root of x to the 6th, that's x to the 6 over 2, which is x cubed. So now, if we have an even root and we end with an odd exponent, that's when you're going to need absolute values. And we're going to need absolute values here because we have an even root and we ended with an odd exponent. So we're going to just put the absolute values around the variable. And we need this because we know that for underneath even roots, we cannot have a negative underneath the radical in order for it to be a real solution. And if this was a negative value for x, if we plugged in a negative value for x, after solving this, you'll still come out with a negative value. So the absolute value ensures that you're plugging in a positive value into your even roots. So this is the answer for that. That is not going to be the case for odd roots. If it's an odd root, you can have a negative underneath, like we did in a previous example. So if we have the cube root of a cubed, b to the 6th, then we're going to still use power over root. So you do a to the 3 over 3 is 1. And then we have b, 6 over 3 is a 2. And then that's it. And then finally, if we have something where it needs to be broken up. So for example, if I have the square root of 8 x cubed y to the 5th, then I know that I need to break it up. I'm going to break it up with my perfect squares and everything left over. So the perfect square that goes into 8 is a 4. And we say 4 times what number will give me 8? That's a 2. The way that you can tell if your variables are a perfect square or a perfect cube is this exponent has to be a multiple of your index or your root. So 3 is not a multiple of 2, but we can break it up. We know that we have 3 x's. So I'm going to put 2 of them here because 2 is a multiple of 2. And then I have 1 left over, so I'm going to put it here. Y to the 5th. I need it to have a multiple. The exponent has to be a multiple of 2. So the highest one would be y to the 4th, and then I still have 1 left over. And now I'll take the square root of my perfect squares. Square root of 4 is 2. Square root of x squared is x to the 1st. Square root of y to the 4th is y squared. Square root of 2xy. And then we need to put absolute values around the x because we started with an even root and this one ended with an odd exponent, so we put absolute values around the part that needs it. And that's it.